So take this question. Alpha, beta are the roots of the equation. If point representing alpha in the Argand diagram lies in the second quadrant and alpha power 2024 minus beta power 2024 equals ik, where I is root over minus 1, then what is the value of k we need to find out. So what is the quadratic equation given? X square plus 2x plus 4 is equal to 0. So if we use quadratic formula is minus b plus or minus root over b square minus 4ac by 2a. That is minus 2 plus or minus root over 4 minus 16 by 2. So that is minus 2 plus or minus 2 into I root 3 by 2. 2 get cancelled. We get minus 1 plus or minus I root 3. So here you can write this as 2 into e power I into 2 pi by 3. Now x is equal to minus 1 plus or minus I root 3, right? So multiplying and dividing by 2. So you will get 2 into. So this we can write it as, if we multiply and divide by 2, we will get minus 1 by 2 plus or minus I into 3 by 2. So that is 2 into minus 1 by 2 is cos 2 pi by 3 and root 3 by 2 is sin 2 pi by 3. So one root is alpha and the other root is beta. So you got over here alpha is equal to 2 e power I into 2 pi by 3. Now we need to find out beta value. So beta is 2 e power minus I into 2 pi by 3. So alpha power 2024 minus beta power 2024 we need to find out. That is alpha power 20. Can I write this as alpha power 2025 by alpha minus beta power 2025 by beta? Now this is 2 power 2025 into e power I into 2 pi by 3 into 2025 by alpha minus, in the place of beta we are substituting the beta value, that is 2 power 2025 into e power minus I into 2 pi by 3 into 2025 divided by beta. So over in from these two brackets, if we take 2 power 2025 common, so you will get e power I into 1350 pi by alpha minus, here also same, e power minus I into 1350 pi by beta. So if we take 2 power 2025 common, so this is e power I into, even multiples of pi will become 1. So this is 1 by alpha minus 1 by beta. So that is 2 power 2025 into 1 by 2 e power minus I into 2 pi by 3 minus 1 by 2 into e power minus I power 2 pi by 3. So that is equal to minus 2 power 2024 into e power I into 2 pi by 3 minus e power minus I into 2 pi by 3. So that is minus 2 power 2024 into, this is nothing but the value of 2i sine 2 pi by 3. Because when you have minus, we take it as 2 sine theta. So that is equal to minus 2 power 2024 into 2 into sine 2 pi by 3 is root 3 by 2 I. 2 get cancelled. That is equal to I into k. You equate this to ik because it is given in the question. This is equal to ik. So from here I and I, if we compare, we will get k is equal to minus 2 power 2024 into root 3. This is the final answer. Now take the next question. If Z1 and Z2 are complex numbers such that mod Z1 plus Z2 equals to mod Z1 plus mod Z2, then the difference in the amplitude of Z1 and Z2 is dash. So first let us see what is given to us. Mod Z1 plus Z2 equals to mod Z1 plus mod Z2. Now squaring on both sides, what do you get? If you square this left hand side, you will get mod Z1 square plus mod Z2 square plus 2 mod Z1 mod Z2 cos theta 1 minus theta 2. And right hand side, if you square on both sides, you will get mod Z1 square plus mod Z2 square plus 2 mod Z1 mod Z2. So these two terms get cancelled on both sides. So you will get, and 2 mod Z1 Z2 also will get cancelled. So you will get cos theta 1 minus theta 2 is equal to 1. So when is cos theta 1? It is at 0 degrees, right? So theta 1 minus theta 2 is equal to 0. So which implies amplitude of Z1 minus amplitude of Z2. Theta 1 is nothing but amplitude of Z1. Theta 2 is nothing but amplitude of Z2. This is what they are asking. So the answer is 0. Option D is the correct answer. Yes, take the next question. This is the simplest one. If I equals to root over minus 1, then 1 plus I square plus I power 4 plus I power 6 plus so on up to I power 24 equals to dash. So let us take the given expression 1 plus I square plus I power 4 we can write I square whole square. I power 6 we can write I cube whole square plus so on up to we can write I power 1012 whole square. Or we can interchange this. Like we can write I square whole cube plus I square whole power 1012. So 1 plus I square is minus 1. Then I square whole square is plus 1. Then I square cube is minus 1. Like that you will get plus 1 minus 1 plus 1 minus 1 will get cancelled. So you will get answer as 1. Because from here to here you have 506 terms positive 1, 506 terms negative 1. So all positive, negative get cancelled and you will be left over with 1. So option D is the correct answer. So take this question. If alpha and beta are non-zero integers and z is equal to alpha plus I beta into 2 plus 7i is a purely imaginary number, then the minimum value of mod z square is. So first let us take z is equal to alpha plus I beta into 2 plus 7i. We will multiply this into this, this into this, this into this, this into this. So 2 alpha plus 7 alpha I plus 2 beta I plus 7 beta I square. So that is 2 alpha minus 7 beta is the real part. From these two, if I take I common, we will get 7 alpha plus 2 beta. Now since z is purely imaginary, its real part will be 0. So what is the real part? Real part is where you don't have I term. So 2 alpha minus 7 beta is 0. So we got alpha as 7 beta by 2. Now they are asking you for mod z square. Mod z square is 7 alpha plus 2 beta whole square. So that is, open the brackets, 49 by 2 or alpha, let us substitute as 7 beta by 2. So 7 into 7 beta by 2 plus 2 beta whole square. So that is 49 beta by 2 plus 2 beta whole square. So if you take the LCM, we will get 53 beta by 2 whole square. So what is the minimum value of mod Z? It will be at beta is equal to 2. So minimum value of mod Z will be at beta is equal to 2, as alpha and beta both are integers. So minimum value is mod Z square. So if we take beta as 2, we get 53 square, which is equal to 2809. That is option B. Now take this question. Argument of sine 6 pi by 5 plus I into 1 plus cos 6 pi by 5 equals to how much? So first, what is given to us? Let us write down. Given z is equal to argument of sine 6 pi by 5 plus I into 1 plus cos 6 pi by 5. So clearly you can see sine 6 pi by 5 comma 1 plus cos 6 pi by 5. So this is a complex number because a plus ib we can also denote it by a comma b. So this is real part, this is imaginary part. So this lies in second quadrant of complex plane. So what is the argument? Argument of z is, if it lies in second quadrant, then argument is pi minus tan inverse mod y by z. Y, since z is equal to x plus iy. For all x is negative and y is greater than or equal to 0. So that is equal to pi minus tan inverse. See, this is not y by z, it is y by x. So minus tan inverse of mod y is imaginary part by x is real part. So that is equal to pi minus tan inverse 1. See, cos 6 pi by 5 can also be written as minus cos pi by 5 by, again 6 pi by 5 is pi by 5. Sine pi by 5 because it lies in second quadrant. In second quadrant, cos is negative, sine is positive. So that is equal to pi minus tan inverse. Now in the numerator you got 1 minus cos pi by 5. So 1 minus cos theta, how can we write? 2 cos square theta, 2 sine square theta by 2. And if you have 1 plus cos theta, that is 2 cos square theta by 2. So we are substituting the value here, that is 2 sine square theta by 2 becomes pi by 10. By denominator is sine theta. Sine theta can be written as 2 sine theta by 2 cos theta by 2. So that is 2 sine pi by 10 cos pi by 10. I will write down the formula here. Sine theta can also be written as 2 sine theta by 2 cos theta by 2. 2 cancel, 1 sine get cancelled. That is pi minus tan inverse of sine pi by 10 by cos pi by 10 is tan pi by 10. Tan inverse get cancelled, that is pi minus pi by 10. Pi minus pi by 10 is 9 pi by 10. So you can say that argument of z is 9 pi by 10. So that is option D. Now take this question. If x plus iy equals to root over 3 plus I by 1 plus 3i, then we need to find out x square plus y square whole square. So x plus iy is given in terms of square root of a fraction. So directly if we rationalize and then solve it, it will become lengthy. So what we will do is, first x plus iy is square root of 3 plus I by 1 plus 3i. So let us take conjugate. This is equation number 1. Now you take the conjugate of each complex number. So x plus iy conjugate is, I am denoting like this. This is conjugate. That is square root of 3 plus I conjugate by 1 plus 3i conjugate. Now x plus iy conjugate is x minus iy, is square root of 3 plus I conjugate is 3 minus I, by 1 plus 3i conjugate is 1 minus 3i. This is equation number 2. Now if we multiply 1 into 2, x plus iy into x minus iy is equal to square root of 3 plus I by 1 plus 3i into square root of 3 minus I by 1 minus 3i. So left hand side will become x square minus I square y square. That is square root of 9 minus I square by. Now numerator is in a plus b into a minus b. That is a square minus b square. And this is 1 minus 9 I square. So that is root over 9 plus 1 by 1 plus 9. Both get cancelled. You get 1. And this is x square plus y square. Because I square is minus 1. Wherever you are getting I square, take it as minus 1. So that is equal to 1. So option B is the correct answer. So take this question. If the imaginary part of 2z plus 1 by iz plus 1 is minus 2, then we need to find the locus of the point representing z in the Argand plane. So first let us find out 2z plus 1 by iz plus 1. In the place of z, let us put x plus iy plus 1 by I into x plus iy plus 1. Now multiply 2x plus 2iy plus 1 by ix plus I square y plus 1. So that is, take real and separate real and imaginary parts in the numerator. By here, ix, I square is minus 1. So this is minus y plus 1. So 2x plus 1 plus I into 2y by minus y plus 1 is real part. Ix is imaginary part. Now we will rationalize it. So we will get minus, multiply and divide with minus y plus 1 minus ix by minus y plus 1 minus ix. Now we need to multiply numerator and denominator separately. So if you multiply numerator and denominator separately, you will get 2x plus 1 into 1 minus y plus I into 2y minus 2y square minus I into 2x square plus x plus 2xy divided by 1 minus y whole square plus x square. And what is given to us? Now from this, let us separate real and imaginary parts. So 2x plus 1 into 1 minus y, this is real part. Then 2xy is also real part. Plus I into what is imaginary part? 2y minus 2y square minus 2x square minus x by. Now let us separate both of them individually. By 1 minus y whole square plus x square by 1 minus y whole square plus x square. So here what is given to us in the question? Its imaginary part is minus 2 given. So imaginary part is minus 2. So from this, what is imaginary part? 2y minus 2y square minus 2x square minus x by 1 minus y whole square plus x square is equal to minus 2. Now you cross multiply. 2y minus 2y square minus 2x square minus x is equal to minus 2 into 1 minus y whole square plus x square. So 2y minus 2y square minus 2x square minus x is equal to minus 2 into 1 plus y square minus 2y plus x square. Now open the brackets. 2y minus 2y square minus 2x square minus x is minus 2 minus 2y square plus 4y minus 2x square. On both the sides, which terms are same, we can cancel them. So minus 2y square minus 2x square are same. Now bring all terms one side. So let us take left hand side terms to right hand side. So you will get x plus 2y minus 2 is 0. So this represents a straight line. So take this question. If omega not equal to 1 is a cube root of unity, then determinant of omega plus omega square plus omega power 9, omega power 9 plus omega power 27 plus omega power 31, omega power 31 plus omega power 17, omega power 17 plus omega power 27, omega power 30 plus omega power 41, omega power 41 plus omega power 19, omega power 19 plus omega power 30. We need to find out the determinant of this term. So let's see how we proceed. So whenever omega problems are given, you should know one concept. If 1 omega square are cube roots of unity, then 1 plus omega square is 0 and omega cube is equal to 1. This is the concept. Now let us take the determinant. Omega plus omega square plus omega power 9, omega power 9 plus omega power 27 plus omega power 31, omega power 31 plus omega power 17, omega power 17 plus omega power 27, omega power 30 plus omega power 41, omega power 41 plus omega power 19, omega power 19 plus omega power 30. Now we can separate them. Like we can write this as omega square, omega power 9, omega power 27, omega power 31, omega power 17, omega power 30, omega power 41, omega power 19. So from each term I took the first number. Then plus, now we are taking the second term in each element. So we get omega square, omega power 9, omega power 31, omega power 17, omega power 27, omega power 41, omega power 19, omega power 30. Now what we have to do is, so we are taking omega common from the first term, omega power 17 common from the second term, omega power 19 common from the third term. So that is omega into omega power 17 into omega power 19. So we are left over with 1 omega power 8, then omega power 10, omega power 14, 1, omega power 11, omega power 22 and 1. Then from the second term, if we take omega common from the first row, omega power 17 common from the second row, omega power 19 common from the third row, then we are left over with omega power 8, 1. omega power 14, 1, omega power 10. Then omega power 22, 1, omega power 11. So here if we add the powers, we will get omega power 37, determinant of 1 omega. See, omega power 8, we can write it as omega power 6 into 2. And omega cube is 1. So this can be written as omega square. Then over here also we can write omega power 20 as omega power 18 into omega square. Omega power 18 is 1 because omega cube is 1. So we will get omega square. Then over here omega square. Over here you will get omega power 1. And here omega square. And here 1. Then here also the same way. Omega square. Here omega and here 1. We are taking multiples of 3. Now over here if you add the powers, you will get omega power 37 and here omega square 1. Then here omega square 1 omega. Here omega 1 omega square. Now if you expand this, you will get the determinant as 0 and here also you will get the determinant as 0. So finally the answer is 0. Option D. Now take this question. If I is equal to root over minus 1, then 1 plus I whole power 10 plus 1 minus I whole power 10. So what is given to us? I is equal to square root of minus 1, which means I square is minus 1. Now if we take 1 plus I whole power 10 plus 1 minus I whole power 10 is equal to 1 plus I whole square, then whole power 5 plus 1 minus I whole square whole power 5. So this is, if we open the bracket, a plus b whole square is a square plus b square plus 2ab plus a square plus b square minus 2ab. I square is minus 1. 1 minus 1 get cancelled. 1 minus 1 get cancelled. 2i whole power 5 is 32i power 5 plus minus power 5 is minus 32i power 5. So that is equal to 32i power 5 minus 32i power 5 is 0. Option C.